two important theorems of moment of inertia. One is parallel axis theorem, second is perpendicular axis theorem. Parallel axis theorem is, if there is any object one axis passes through its center of mass. This is center of mass, and KL, axis KL passes through center of mass. Any axis, randomly any axis, AB. Distance between AB and KL is h. Then the theorem is, moment of inertia of this object about this axis AB. That means if you rotate this object about AB, its moment of inertia about AB is equal to moment of inertia about KL plus mass of the object into square of the distance between the two. This is the outcome. This is what we want to prove. Means moment of inertia of an object about any axis AB is equal to moment of inertia about an axis passing through center of mass plus product of mass and square of a distance between the two axes. This is what we want to prove. First, we take into account the concept, that the derivation concept, that is for one particle. If there is any particle, one particle m, it is at distance r from KL, this distance is h. If you rotate this particle m about AB, then if this particle rotates in a circle, the radius will come out to what? R plus h. So moment of inertia about AB is equal to m r plus h square, because as per the definition, moment of inertia is mass into square of perpendicular distance. Perpendicular distance from axis of rotation. It is r plus h. What you get is m a plus b square, a square plus b square plus 2ab, r square plus h square plus 2rh is equal to mr square plus mh square plus 2mrh. This mr square, we will do it for all particles. For this particular particle, only one particle, m into r square is what? Yes, r is its perpendicular distance from which axis? KL. So that is why we can write it this as IKL plus m for all particles. This is for one particle. When we take up for all particles, we write capital M h square, and this m into r. For one particle it is not 0, but for all particles we will prove this value will come out to be 0. This is the concept, that moment of inertia about AB. Based on this concept, now we will proceed for derivation for all particles. Time with you is 3 minutes. One full page. Now the complete derivation. Moment of inertia about AB is equal to particle number 1, m1, at what distance? r1. So moment of inertia of this particle number 1 is m1 into r1 plus h square. This is one particle. Particle number 2, m2. It is at what distance? r2 from KL. This distance is h. m2 is at what distance from axis of rotation AB? r2 plus h. So its moment of inertia is m2 r2 plus h square. If there are n such particles, then for nth particle it is mn, rn and h comes out to be what? mn rn plus h square. When you open the bracket, a plus b square m1 r1 square plus h square plus 2 r1 h. Second one, I will write exactly below this, m2 r2 square plus h square plus 2 r2 h. For nth particle, mn rn square plus h square plus 2 rn into h. What you get is, yes, if you add all these, m1 r1 square, m2 r2 square, mn rn square, it is sum of what? It is sum of mi ri when I varies from 1 to n square plus m1 h square, m2 h square, mn h square, h is same, it is h square, sum of masses I varies from 1 to n plus m1 r1 h, 2h is common, so 2h, and what you get is m1 r1 plus m2 r2 means m1 r1, m2 r2, mn rn, sum of m and r I varies from 1 to n. What does this mean? M into r square, m into r square, m1 r1 square, m2 r2 square, mn rn square. It is moment of inertia about KL. Moment of inertia about KL plus sum of all masses m1 plus m2 plus m3, sum of all the masses on the body means mass of the object. It is h square capital M, and this part MIRI is equal to 0. Why? For an example, one mass is m1, 1 kg. m2 is also 1 kg. This is a distance 1i, r1. This is a distance minus 1i. This is the center of mass. m1 into r1 is how much? 1 into 1, 1i. m2, it is also equal to 1 kg into minus 1, minus 1. So m1 r1 plus m2 r2 comes out to be equal to what? 0, because r center of mass was equal to what? m1 r1 plus m2 r2 over m1 plus m2. If r center of mass, if you take this as origin, if you make all measurements from where? From center of mass. If you make all measurements from center of mass, then r center of mass is 0. It means m1 r1 plus m2 r2 will be 0. If there are 3 particles, m1 r1 plus m2 r2 plus m3 r3 will be equal to 0. If there are n particles, even then this thing, if you take center of mass as a reference, comes out to what? 0. So moment of inertia about AB is equal to what? Moment of inertia about KL plus mh square. means moment of inertia of this object about any axis AB is equal to moment of inertia about an axis passing through center of mass IKL plus product of mass of the object and square of perpendicular distance between the two. Time with you is 4 minutes. B part of the same deals with what? Yes, perpendicular axis theorem. B part deals with perpendicular axis theorem. Theorem is any object, say a plane lamina like this. So if I treat this to be as x-axis, this is x-axis. So you can have a rotation about x-axis like this. It is moment of inertia about a x-axis, rotation about x-axis. If it is so, it will have y-axis also, this one. This was x-axis, sorry. This is y-axis. So you can have rotation about this also. That is moment of inertia about a y-axis. What about this one? It is towards the reader. This was x-axis, this was y-axis, this is z-axis. So how you have rotation about z-axis? Like this. So you can have rotation about a z-axis also. So if there is a plane lamina, plane sheet, and you have three axes, x, y and z axis. So this is x axis, this is origin, this is x axis, then y axis. What about z axis? Z axis is towards the reader. It is to be marked like this. Dot means what? Vector pointing towards the reader. So this is z axis. First we will take up the concept part of the same. Derivation concept for one particle. Notes band kar do. A particle of mass m and its coordinates are x, y means what? This horizontal distance is x, vertical distance is y. Moment of inertia of this particle about x axis. Right? 2 minutes. 2 minutes to draw the diagram. Moment of inertia. Of the particle about x axis. Yes. It will come out to be equal to what? Yes, comes out to be what? Anyone? moment of inertia of this particle about x-axis, my square. This is the axis, x-axis. So you have to rotate this particle about x-axis. When you rotate, this radius will come out what? Y. So it is m into y square. This is one equation. Moment of inertia about y-axis. Same particle. When you rotate it about y-axis, this distance is equal to what? X. So it is mx square. Add equation number 1 and equation number 2. Ix plus Iy is equal to my square plus x square. X square plus y square is equal to what? Yes, x square plus y square. Please don't say it is equal to z square. There is no z. This particle lies in xy plane. It has x coordinate, y coordinate, its z coordinate is 0. So if you say x square plus y square is equal to what? It is equal to r square. And r is perpendicular distance of this object from which axis? Z axis. That is why it is equal to what? It is equal to mr square is equal to Iz. What is perpendicular axis theorem? Theorem is moment of inertia about z axis is equal to moment of inertia about x axis plus moment of inertia about y axis. This is what perpendicular axis theorem is. 3 minutes to complete. Complete derivation. This was a concept for one particle only. There are n number of particles. Let this mass be m1, distance x1, y1, coordinates x1, y1 and r1. So, moment of inertia about x-axis, Ix is equal to m1, yes, y1 square. Let there be another particle, mass m2, coordinates x2, y2. So, second particle, yes, by logic, m2, y2 square. And how many such particles are there? N. There is a particle mass mn, coordinates xn, yn. So, its value will come out to what? mn yn square. Similarly, Iy is equal to what? m1 x1 square, m2 x2 square up to mn xn square. Again, add the two. Add equation number 1 and 2, what you get is Ix plus Iy is equal to m1 is common, m1 x1 square plus y1 square, m2 x2 square plus y2 square. For nth particle, mn xn square plus yn square. Yes, x1 square plus y1 square is equal to what? r1 square, m1 r1 square, m2 r2 square. No doubt it is r2 is not marked here, but you can work out mn rn square. This is what? m1 r1 square. m1 r1 square, perpendicular distance from z axis. So all these particles taken together it is Iz. So Ix plus Iy is equal to what? Iz. 3 minutes to complete. 3 minutes to complete. Conclusion is again moment of inertia about x-axis. This is the x-axis. So moment of inertia about x-axis plus moment of inertia about y-axis. This is the y-axis. Moment of inertia about y-axis is equal to what? Moment of inertia about z-axis towards the reader. So moment of inertia of a plane lamina Iz is equal to Ix plus Iy.